right? So before jumping into the static, I really want to start from an earlier point a little bit. What we discussed last time about the life duration of variables. We said that if you define a variable within a block or within the main or within another function, then this variable will only exist in the memory while this function is being in call, right? For example, if I go back to one of our examples here, which is my mean square, once you start calling, let me see, once you start the function call, so at this point in time, which is you already declared, let me choose a pen. Okay, so at this point of time, oh, come on. Should I stop sharing and then reshare? Okay, so the same bin issue as before, which is not that good, especially for today's lecture. Okay, try the other one, see if it works. Okay, so I'll try to use my hand. You'll not be very happy with my drawing on hand, but yeah, let's see how it goes. So simply, well, so it's not a bin issue then. It's a PowerPoint issue. Okay, so I'm reloading the slides. Let's see if this gets fixed. I can try to utilize the time for questions as well while it comes up. Let me check back again if any of this works. Come on. Okay, should I just open the PDF then? Let's see. I'm gonna try to draw. Supposed to be connected. That's interesting. Maybe I would just reconnect. See how it goes. Okay. Sorry guys, I guess using the pen for today's lecture is really critical because we need a lot of writing and pointing. It's not much coding, so I want to make sure I get this working. Let's see.
Yeah, it's all good.
I think you're muted.
Oh, thank you. Thank you. Yeah, what I was saying is that I will start the tablet, and then I will use the slides from here until I restart. Because something I kind of discovered lately is that Microsoft sometimes forces you to restart and update by disabling some of the system functionality, which is very bad, but yes, we have to deal with it. Okay, so I'm opening the slides from here. I will not be able to go full screen on my desktop because it's a very wide monitor, so it will appear very small to you, but I will just show this as the normal slide view, and hopefully you should be fine with this until we restart. Okay, so something we discussed last time. So you are able to see my slides, correct? Is that good? So you see the slides, you see. This is we went through last time, but it's very important to understand because it's related to the static variable. We said if you define a variable inside a certain scope, then the lifetime of this variable is really attached to the scope itself. Just to understand exactly what did I mean by this kind of theoretical statement, go back to the example we had, which is this my mean square function we defined, right? We said before you enter your function call here, in fact, all the x, y, z didn't exist before, right? Like until I really call my mean square passing a and b, x and y and z don't exist. Okay, good. And then once you do the function call, all the variables or the local variables of the function get created in the function stack space. And then once you are done by the function call at the return or at the end of the closing bracket, if you don't have a return, all of these variables that are local to the function will also get destroyed in memory, right? So if you take a memory snapshot, and this is very important to understand, right? If you took a snapshot for your memory of your program before doing the function call, you will never see x and y and z. And if you took it after you finish the call, there is no x, y, and z. There is no even a space for this function, like memory space. Everything related to this function, including its local variables, gets defined in the memory when you do the call and gets destroyed from the memory when you really end the call. Good. So the lifetime of a variable, this is exactly what we mean by the lifetime of a variable, is how much time it remains in the memory. Good. Understanding this, going back to the static variable, what if I want to really define a variable that is independent of this automatic life cycle, right? Something that remains for the memory, for example, for the full execution duration of the program, right? Why I would like to do this, right? One possible use case that you want to do this is you want to carry forward. Assume I do a function call right now, and then I want to carry forward some of the results to the second function call. So you keep calling a function multiple times, and you don't want to lose your old value, right? As we will see in the example right now. To be able to do this, you have to define your variable as static. And from the word static, it means, well, it doesn't really get destroyed when you exit the function call. Good. So to summarize what I have been saying, well, if you define something as static, its lifetime in the memory exists from the beginning of the program, which means when you start executing the first line of the main until the end of the program, right? So it's not associated to a certain scope. And because functions and global variables, we said their scope is the program itself. So by nature, they really exist in the full execution time of the program, right? This is something that is also good to understand. Is from last time we mentioned that all global variables, they don't have an associated scope. They are accessible by the full program, which means their scope is the program itself. And hence they live in the memory as far as the program is getting executed. Does this make sense? And then a function local variable can acquire static duration if you define it as static. So by default, all the variables within a function or within a certain scope only exist while the scope is executing. But if you want to keep it static, then you have to write the static reserved word in front of it. Good. And then all numeric static variables are initialized to 0. That's something that differentiates between a static variable and a normal variable. Remember before we mentioned multiple times that if you don't initialize a variable, it gets any garbage in the memory space that was there before, right? So guys, stop using the chat for funny stuff, okay? Because if you do so, it become even harder for me visually to scan the questions, right? I like jokes myself, but well, let's be a little bit more efficient. Good. Okay, no worries, Jack. Okay, so the point is that if you want something to remain in the full duration of the program, not just associated to the function, you have to use the static reserved word. And then previously, any variable that is not static really does not get initialized to 0, right? So it gets whatever garbage memory was there before, whatever value was there in the memory, and this might cause issues. And we said it's a very important programming practice to initialize all the variables you define, correct? Static, because they remain for the full execution of the program, they get initialized to 0 by default, right? So you don't have to do this. That said, it's really still a good practice to just initialize everything. Good. And then static variables exist all the time in memory, but we already mentioned this. Good. Something that is very important to understand is that being existing in the memory for the full execution of the program does not change their scope, right? So if you define a static variable inside the function, it doesn't mean that really it is accessible from another function, because the scope is one thing and the duration in the memory is another thing. And these two concepts are really different from each other, right? You might see what I'm saying is something that is not really very related to programming, and then it's a little bit boring, but that's really a very fundamental concept. Like this, what differentiates again someone that is taking programming as a hobby and someone that really understands what's going on. And some issues you will not be able to resolve except with understanding this kind of low-level knowledge, right? And usually again for interviews or for testing someone's ability to really understand the programming, people tend to use these kind of concepts, right? Because they go beyond the surface, right? They kind of see whether are you just like wrote a couple of lines of code or you really understand what is going on. So let's see an example, because this example will help us. Well, this example would have been much better if we really do the animation, but let me do something instead. So I will just go ahead and use online GDB for that. select C. I'll stop sharing this one. I'll switch to sharing my Chrome. Okay. So I hope you are able to see online GDB. What I will do is I just copied the program. Just keep this one in. Remove this one. Get this one like this and make it a little bit bigger. Okay. So what I have done right now. First of all, let's just remove the word static. I'm just writing a very normal function. I called function. This function, well, it's a good review for the functions anyway. So I'm returning an int. I'm taking a single input parameter. It's called A1. And then it seems here what I'm doing is I'm initializing a variable to B, another variable called C, increasing B and C, and returning the sum of the input variable and then B and C. In the main, I'm calling my function and I'm printing the return value. Good. So it's as simple as this. I'm doing this really for the duration of 3 times. Good. If I'm doing this and I'm running the program, I should see back. First of all, like, well, that's also a very good thing to test the initialization. Let's see what happened. First of all, I have 3 prints. Why that's the case? Because, well, I'm doing the printf inside the for loop of 3 iterations. Good. Then the first one is 4. Why that's the case? I pass 2, which is A here. And then I'm adding 2 to B. What is the value of B? It's 0 and then increased by 1, right? So here in the first iteration, I'm really adding 2 plus 1. And then C. I didn't initialize C, but then, well, I'm incrementing it. It seems that because I got a value of 4, I was lucky enough that C this time really got initialized to 0. And then I added 1, so it gives me 4. Correct? In the third iteration, let's keep the iterations really in line by line. So this is first iteration. In the second iteration, again, I'm passing A. I never changed the value of A, so I'm still adding 2. In this function call, again, I'm redefining B, initializing it to 0, incrementing by 1, so B is still 1. And then all of a sudden, I got a result of something that makes no sense to me. There is no copy here. It's bad. Copy. And then that. Oh, what did I do? Is there Control Z? Good. And then I got this value, right? What does it mean? It means really C got the value of 3, 2, 6, 1, and then 1, correct? Because this is what gives you this number. But where this value came from? What do you think? Why I have C as this value, right? Just write on the chat, like say anything.
Did it get that value from a different memory location or something?
Yeah, I got the value of, like, when I define C, it gets allocated in the memory. And then because I didn't initialize it, so I didn't override this memory location. So I got what was there, which I guess Ahmed is also saying in the chat that, well, it's supposed to be random. Yes, it's not completely random because random means something that is not expected. It's really related to a value that was there before, but I don't have exposure to this value. So I don't know what is this value, right? So it seems that in this memory location, in this second iteration, C get allocated to a place that originally had 32610. Right? And then I incremented C by 1, it gives me this value, and then that's the sum. If you look into the third iteration, you might really be even getting something different or the same. Well, this really completely random, as Ahmed is saying, you don't know what value you will be getting, right? And then, well, you do the same thing. Good. How to solve this problem? What do you think? If I want to get something that really makes sense to me, what should I have done?
C.
Sorry, can you say this again?
Initialize C.
Initialize C, thank you. Yes, so if I initialize C, everything is predictable right now because I know exactly what value C will get. So I run every time I will get the same value, right? Because, well, I'm adding 2 to 1 and 1, so it gives me 4 all the time. There is no unexpected value. So this tells you really why it's very important to initialize variables in C. Now, let's add one thing, which is the static, right? So right now, well, originally without the static, B and C are exactly the same thing, right? Initialize to 0 every time I do the function call and then increase 1. If I add static to int C, well, things will become a little bit different because C does not get destroyed and redefined every time, right? So if I run this time, I get 4, 5, 6. Why that's the case? Let's see. So in the first iteration, A was 2, B was originally 0 and then incremented to 1. And then C was 0 and then incremented to 1, correct? So the sum will be 2 plus 1 plus 1, which is 4, correct? In the second iteration, though, it's something little different. A is still 2. B is really still get initialized, defined, redefined from beginning, and then incremented to 1. But C, because it's a static variable, it never get destroyed in the first place, right? So it carries the value forward. So C in this point is not starting from 0, it's starting from 1. Where did this 1 come from? It really came from the previous call of the function, right? Because C carries forward the value across different calls, right? And then it gets incremented to 2, which gives me the sum of 2 plus 1 plus 2, which is 5, right? And then in the third iteration, the same thing. So as you can see, by defining something as static, it does not get destroyed when the function returns, which means it holds the original value and it keeps keeps incrementing. Yeah, go ahead, Samuel, if you have a question. Yes, there was a hand up. Ahmed, also your hand is up. Feel free to ask.
Hi, yeah. I had a quick question. So, you know how like the first time we ran it, it like went perfectly fine for the first iteration, but then used that like new like strange number that we didn't set as the second and third iteration. Why was the case that it didn't happen in the first one? So,
Because
like,
you don't know, right? It seemed that what has happened is that C got allocated to a place that just by chance had the initial value of 0, right? So you really don't know this. That's
okay.
something that really you have no control on because it depends on where the hardware is placing C in the memory, at which address, what value it had from before, right?
So if
it's
we
something
ran it,
that, yeah, sorry, go ahead.
so if we ran it like multiple times, we would probably get different answers each
Exactly.
time.
Yeah, this is what
Yeah.
we have seen also in these 3 iterations, right? First
Yeah,
time it was 0, the second one it was different number, then etc. So yes, that's definitely the case.
Okay, thank you.
So what static does is, does it make sure that C is allocated to the same space and memory each time?
Yeah, but this statement is correct in a sense and wrong in another sense. When you say this, it seems as if C gets really reallocated every time, but it's reallocated to the same place, which is not the case. C does not even get destroyed when the function returns back. So it gets allocated only once in the first function call, and it remains there, right? And this is what we mean by static.
So
Does this
putting
clarify
static
things a
here
little bit?
basically extends the storage duration.
Exactly. Yeah. So static controls the lifetime of the variable by not being destroyed, and it remains until the end of the execution of the program. That's correct.
Why isn't C reinitialized each time you enter the function? Because you're still each time you enter it still says static and C equals 0.
That's an excellent question. The question here is saying, well, each time I enter this thing, I still have this line, right? And I am assigning C to 0, so it should really get overwritten to 0 every time I do the call. Well, static is preventing this. Static is saying, well, when I define the variable for the very first time, I give it the value initialization of 0, but afterwards I don't even redefine it. So once I see the word static, I know that this variable has been existing from before. Don't reinitialize.
Okay, that makes sense. Thank you.
So is this a result of the fact that when we said like int C without defining it to 0, and we got like 32,114 or something like that, that's because C doesn't have automatic garbage collection, right?
Yes, that's correct. Partially, yeah. Well, it doesn't have automatic garbage collection, but it has other implications. But not initializing variables is not directly related to the automatic garbage collection. Later on, when we discuss pointers, it like garbage collection becomes more of it will play a more role. But really, this is related to how the language is being defined as the standard. For example, C, the same language, which does not have any garbage collection. If you define an array, declare it without initializing it, it really initializes everything to 0 in the array, right? So, well, if it's related to garbage collection, arrays wouldn't be initialized to zeros by default, right? But this is basically depend on how the language is really being defined, right? So what I would say, what the language is promising you to do, because at the end, in the language standard, the compiler is implementing this standard. So it says, well, if I'm initializing arrays, then the compiler behind the scene will do it for you. But if I'm not initializing variables, it will not do it for you, right? So it depends on really what, it's a rule, basically. It's something that there is nothing correct or wrong. It's mainly related to what do I promise as a language the users to do, right? Java, for example, well, it says, well, I'm initializing everything to 0. I have automatic garbage collection. It's much easier. I'm doing most of the work for you. But C is really the trend, as we said before, is very important to understand the philosophy of the language, which is, well, I give you the full control. You are the responsible of what you are doing, right? So if you don't want to initialize, well, it's up to you. If you want to initialize, go ahead and initialize it. So it's strict language in that sense. Okay. Question, what happens if both B and C are static? Well, B will behave exactly the same as C. So each time B will carry forward the value, so it will not get initialized to 0 every time. Well, you see how C is behaving, B should be exactly the same thing. Right? Sana, is there a way to clear the memory when you have a static variable? Well, no, there is no way. Right? If you just define it as static, it will remain until you end the execution of the program. Good. Are there other questions? Okay, so hopefully I do one last trial for the tablet and it works good. So I will, so we are done with the static, which means I will just open the other slides from the tablet then. But again, feel free to ask, could you have used the global variable outside the function instead? Yes, definitely, you could have. But there is a very big difference between global variable and the static local variable, because we said there is a difference between the duration of the lifetime of this variable and its scope. And that's really something that might be really worth trying. So here I'm defining NC as static, right? What if I try to say here, even after I do the function call, give me C equals C plus 1, right? Well, this is a static variable. I know it exists in the memory across all over the program. If I run it, well, C is undeclared, right? Why? Because scope is one thing. The C scope is only within this function. It's only accessible within this function, but life duration is another thing. So it's basically like the time dimension and the space dimension. The space dimension is when you can access this variable, and the time dimension is whether the variable is there or not. So the variable is there all the time if it's static, but you cannot access it except from its local scope. If you define C, on the other hand, as a global variable, you can really access it from anywhere. So global gives you another privilege, I would say, which is you are able to access your variable from everywhere, which static is not. So it's a different use case. Good. What would you have happen if you didn't define C and made it static? Would it just add on that random number? If I didn't define C, it will be undeclared variable, but I believe what Suhail you mean is that if you didn't define it as static, right? If that's the case, sorry, I'm kind of confused. I'm not sure if I got the question. So if I didn't define it, you don't have access to it, it's undeclared. If I didn't define it as static, similar to what we tried before, it really just get recreated every time, right? So if that's the question.
I think they're asking like if you just put like static in C.
And you didn't initialize it.
Yeah.
Is that the case? Then we said, yeah, thank you. So if that's the question, then if that's the case, we said static initializes the variables by default to 0. So you really wouldn't get any difference, right? So I'm just remove this wrong coding. And then doing this would give you exactly the same result. And the reason is we said static variables get initialized to 0 by default. Good. You don't need really initializations to the static variables. Yet it's a very good practice to keep it. So make sure you really stay consistent. in your programming style. Okay, even if it's not needed, well, there is no harm of adding it. Good. Okay, so now we are sharing back from the tablet, and we have the pen. So let's look into some of the theory stuff. We visited this before. You know most of the rules, but it's very important to have, I would say, a reference point to say, well, if I'm confused about anything, what is really the rule? And then you visit this lecture. Okay, so the style we have done so far is we started by hands-on. We wrote few examples. Along the way, we were learning the rules partially or completely based on how hard or easy to do it through coding. But now we take a pause, we stop for a second, and we go through some of the rules, right? And then, well, it might be a little bit boring to do so, but it's very important. And the reason is, well, if you, while coding, while doing the lab, for example, you kind of not very sure what is the rule here, what is the type, what is the specifier for the printf, for scanf, then you go back and visit these slides. Good. So again, what we have wrote so far is we wrote like some kind of code. Well, we have already submitted lab 0. I hope everyone has done so. And then we saw, while coding, we saw variables, arrays, loops, conditional statements, and functions, which I'm happy because I think it's really a lot to do in a language in 2 weeks. But then again, we need this jump, right? We need to take the pause and really look into the rules in general, right? I didn't want to start with this because I didn't want you to get bored from the theory, but again, we have to do it. There is no way we can bypass this. So variables, what are variables? Well, those are placeholders for the values I want to carry forward in my program, right? And their value can really change during the execution of the program. Any variable, you should really have a type, a name, and well, we said it's a good practice to just initialize it, right? And then the variable name, well, you should really start with a letter, and then you can add like underscore digits. You cannot really have special character other than the underscore. The maximum length of a variable is 31 characters. It's case sensitive in C. So if you define int x and int x, these are two different variables, right? Like it's case sensitive. And then, well, the variable name cannot be a keyword. For example, you cannot say int 4, right? That's not allowed because I'm not sure in CombEng we really offer a compilers course. But if you had the chance to look into compilers, you know that really the compiler, if well, again, what is the reason why not allowing variables to be keywords? Because those keywords are part of the C standard, which the compiler uses to understand your program. So if the compiler hits a word 4, it will interpret it as if you have a for loop. But then, well, if you are allowed to use it as a variable, this is very confusing, right? So variables cannot be any of the reserved words of the language. Good. And then you in C, you really have to declare the type of the variable. In Python, you didn't have to. Even in Python, in fact, you can use the same variable name and change its type along the way. You can initialize it as an int. Later on, you assign a string into it. Well, it keeps changing. In C, this is not possible. And again, this is maybe because C is a compiler-based language and Python is an interpreted language. So it keeps, and this is what makes Python really slower, because each time you really kind of executes line by line along, like on the fly, while in C, the compilation process is offline. It gives you executable, and this is what's going to run, right? Okay. And then what the type really means, well, some of this you already know. Some might be you never articulated in your mind. So the type tells you, well, the first thing is the set of possible values. And that's something that most probably is the thing that you had in mind. If you define a variable as int, then you cannot say int x, and then you assign x to 1.5. While in C, it will do type casting, so it will just store 1 into it. But let's say that's really not a logical thing to do. If you want something to be floating point, you would rather use a different type than int. So the type tells you what are the set of allowed values of the variable you define. But another thing you might not have thought of is really the type also dictates how much memory you need for this variable. If you define something as an int, it tells you that, well, this variable is going to take, for example, 4 bytes in the memory or 32 bits, right? But if you define something as float, or let's say double for now, because float might be more also 4 bytes. If you define something as double y, this tells you that double most likely is going to be either 8 byte or 16 byte, depends on the machine, right? So if you define something as character, this tells you it's a single byte. Why that's the case? Because if you think a variable type dictates what are the possible values, and based on how many possible values and the type, you really know how much memory you need, correct? For example, if I define something as character, you cannot store ABC into it. You can only store A as a single character or B or C. But a single character can be interpreted, as we will see later on, as a single byte or 8-bit, right? So it's enough to store the variable in 1 byte if it's a character. Good. And then the third thing is the type also tells you what operations you can perform in this type of variable, right? So is division allowed? Is mode operation allowed? Or maybe is concatenation allowed if you're talking about strings and characters. So what operations you can perform in the variable are really dependent on the type. Good, as we will see also a few examples. Some of the basic types we have used. We used int. There is a character. Have we used character? I'm not sure. And then int also have some kind of subtypes. If you want an int, generally int takes, well, 16-bit is in very old machines. I don't think any of your machines right now will define an int as 16-bit. This was something a while ago. Usually it's 4 bytes or 32 bits. But then short int is really something that takes a smaller number of bytes. Usually it takes, instead of 32 bits, takes 16 bits only. And then long int takes really something more than 32 bits. It takes 64 bits. So int has some other kind of, I would say, identifiers that can modify how much memory you can store. And therefore, it also defines what is the allowed range of values, right? Because if your int, for example, is 32-bit, well, how many distinct variables or distinct values you can really have, or combinations you can have out of 32 bits? Is 2 to the power 32 minus 1, right? I guess you might have also touched on this a little bit on your digital design course, right? With Dr. Bowman. So if I have 32 bits, if I want to list all the combinations, it's 2 to the power 32 minus 1, right? And because int is generally signed, so it can be negative or positive, then really the set of values is this, then 2 to the power 16 minus 1, right? Because half of the values can be negative, half the values can be positive, and then I broke the half of them to that, right? This is how we determine really what are the set of allowed values. For example, if you want to test the limits of this, you can define an int in your compiler and then give it a very, very large value, like 2 to the power 64, right? This will not work. It will give you either memory overflow or gives you segmentation fault. It depends really on what you want. Why do you -1? Well, because int can be signed, well, or -1 is still an integer variable, right? Like it's a valid like integer number, and you have to make sure you represent it. Good.
Sorry, Professor. I think the person that asked about why do you -1, I think they were referring to when you were doing 2 to the 32 minus 1.
Oh, I see. Okay, because, well, let's take the 4-bit case, an easy case. If you have 4 bits, what are the maximum value of combination you have? It's 1, 1, 1, 1, right? If you, this is the binary thing. In decimal, 1, 1, 1, 1 is what? It's 15, not 16, right? Which is 2 to the power 4 minus 1. Correct? That's how you get it. Like if you assign all the values to ones in the number of digits you have, you really have to the power the n digits you have -1, right? This is why you, like if you have ever confused, just take a very small example and walk through it, right? I hope this answered the question. There was another question from Hauman. Is there any reason you use int, short int, other than saving memory? Well, saving memory is a big deal in C. In fact, Hauman, if you know that you will never need more than this, so it's a good practice to really use short int. But there is no other reason. Like it's mainly about efficient memory handling, right? For example, if you are using C for embedded systems, that's a big deal, right? Because your memory is very precious and you have to make sure you really don't waste it unnecessarily. Good. Now, IDEN, that's yes. Well, maybe I kind of answered it from another angle, but that's definitely the reason. It's also because you can start the value from 0 and then you have to reach to the maximum -1. That's correct. And then we have float, which is single precision floating point, and then we have double that we used, well, quite few times, which is double precision floating point. And then, in fact, if I want something that is very long as fraction, that's long double, right? Which is an extended precision floating point. And then I can add specifiers to signed and unsigned. I said, for example, int is signed by default, correct? But what if I know that my use case, my application, is going all the time to have something as positive number? Assume, for example, you are defining a variable to count how many cycles or how many minutes you spend on doing something. This will never be a negative number, right? So if that's the case, maybe you can save your memory. You can use the full range of 2 to the power 32 minus 1 by defining your variable as unsigned int. If you do this right now, x, because all the values will be positive, you can really have a range of 2 to the power 32 minus 1 instead of 2 to the power 16 minus 1. Because right now you saved half of the values of the negative, you add them to the positive number, correct? Okay. Usually one thing related to this that also people kind of touch on a digital design course is why really, if you have positive and negative, you take half of the values. Does anyone know why really, if I know that my int is like can be positive or negative, I can really have a range of positive negatives and then to the power 16 minus 1 instead? What do you think? For example, assume I have 4 bits. Just again, take a simple example. If I know that all my numbers are positive, then I can really encode from 0 to 15. That's only positive. But if I know that they can be positive or negative, I only can have from -7, +7, correct? What is the reason? One bit is used for exactly, and that's correct, because the last bit in case of signed is usually used if it's 0, that's a positive number. So these are called sign representation, right? There are multiple representations for negative number, like Mantesan sign, by using the last bit as the sign, or 2's complement. So if you hear these things in your digital design course, you kind of understand how machines interpret binary numbers, and then you also see their implications in programming, right? But just to answer the question again, if someone didn't get Anna's answer, is simply because I have to dedicate one bit to indicate whether my number is negative or positive, like sign, or like if it's negative, then the bit will be 1. If it's positive, it will be 0. And then I only left with like 3 bits instead of 4, and the range for 3 bits to the power 3 minus 1, which is 7, right? Good. Okay, good. And then some of the arithmetic operations. Well, we have the unary operators like plus or minus. We have binary operators, which is like when we say unary. Well, in fact, you can, as we will see later on, you can really take a unary means like we have a single operator. We have seen this in the for loop sometimes, is that you can really increment a variable by doing plus, right? We'll come into this. And then that's addition, subtraction, multiplication, division, excuse me, mod. And then we have tried all of this. Then some of the rules here, some of the tricks that is very important to understand. In division, in C, if both operands of the division are integer, then you will really have an integer division. It will not give you the correct value you are looking for. For example, if you are dividing 5/2, assigning this to a variable called z will be 2, not 2.5. Why? Because this is a division. Division is saying if my both operands are integer, the result must be integer. Then it rounds the results from 2.5 to 2, right? Usually this is something that causes some confusion and gives you some incorrect results. If you track this back, if you want your division to be in the correct format, then you either define one of the operands to be float, or you have to really cast, as we will see later on, okay? Yeah, someone already came through this in the lab one, so that's good to hear. Does integer division always round down? Yes, it truncates. Correct. I see some hands up, so please, if you have a question, go ahead.
Yeah, I was wondering about the signed applying to a char. I know char is probably represented in the system by a number, but what would a signed char be useful for?
It's not really so. Okay, so good. So that's a good question. So here, by saying that I can really apply signed, unsigned to all these types, it's really because under the hood in C, as we will see later on in some detail, and as you said as well, character is represented as an int number, right? So at the end, it's really like we'll see later on. If you really define a character as A, and you want to print it as an integer, you'll get the exact encoding value of A, which is the ASCII code, basically, right? That's the reason why you can still apply sign to character. Does it mean anything? No, right? Because you really don't have to do this. But the point is that these are rules, and to put rules, you have to see what is happening behind the scene. So a character at the end is an int, right? So whatever applies to int, the language should hold for the characters as well, right? That said, assume I want to deploy some sort of an integer operation on character values, right? And then how to interpret these values, whether they are signed or not, then this might cause a difference in the result. What do I mean? You can write a program. I don't want really to jump into this now because later on we will touch on how character is represented as an int. But simply, you can use a character and then use some integer operations on it. Those integer operations, their result will depend whether your values are signed or not. And then the result will change. If you define your character as signed, which is really by the default, everything is signed unless you specify it's unsigned. And that's something that we didn't mention, in fact, right? That all these types, character, int, short, long, are signed by default. You really don't have to write signed character, right? If you want it to be unsigned, then you have to write the reserved word unsigned. But going back to your question is that the result will depend whether you interpret the values of the encoding as signed or unsigned, right? Maybe it's something I can add to the example I have later on for characters and how to deal with them as ints, right? But that's a good question. I guess there was another hand up. Yeah.
Also, so by default, when it is interpreted as a character, it uses like the ASCII.
The ASCII representation, correct.
I see.
Yeah, and then later on we will discuss this and we'll see the ASCII table and how to really. There are some kind of very good kind of questions like interview-like tricks on how to deal with this. So we'll see them. And usually I like, well, back then in the old world when we had like written exams, I used to have like multiple choice where we have so many of these tricks. But right now, well, I don't think you encounter any of that. Okay, so we said that. And then another thing related to the reminder, well, we have also seen this before in the example where we conditionally added the input from the user to the sum if it was odd. Remember this example we have wrote in the second lecture, right? We said reading, I don't know, 10 integers from a user or 20, only add them to the sum if they are odd, right? So we use the modulus operation back then, which gives you the reminder of the division, not the division result, right? And then modulus some of the rules, it only applies to integers, and then yeah, it gives you the reminder. For example, 18/4 gives you 2, because 18 over divided by 4 is what, 16, and then you have 2/4. So this will give you the modulus thing. Is there someone playing with the recording? And then this is the division result, right? Questions? I guess, Tyler, you have your hand up. Please go ahead.
Sorry, I didn't mean to raise my hand, but.
Okay, good. Okay, thanks. Then let's see, so like taking those kind of expressions, how to evaluate some kind of complex expressions in C. The good thing is that really regular expression operations is like more a math rule. So it applies to any programming language. It even applies to high school math or calculators. So you already know this from before. For example, here, I do know that I need to do Well, like division and multiplication have the same priority, and then addition and subtraction comes afterwards. So what you should be doing as an order is that you will divide, then multiply, and then add, right? So you divide 7/9. What does it give you? 7/9 in C. What do you think? Based on what we said, what's it going to give you? 0, exactly, because it's an integer division. Multiply this by 3, still gives you 0, and then adding 6, so it gives you 6, right? Is how you evaluate it. Yeah, thank you, Borna. So I guess I need to revisit again the settings in the teams. There seem to be some kind of security vulnerabilities there. Okay, so those are like precedence constraints, but as I was saying, they apply to almost all languages. So the good thing is not much new information here. Well, if you have those parentheses, they take the highest precedence, right? So always execute with what is in the brackets, and then the pre-increment and post increment. This is usually called post increment, not pre, right? And then that's well, that's a not. So unary operators generally really comes after the parentheses, and then the multiplication, division, modulus operation afterwards, and then addition, subtraction, and then if you have any relational checkers, and then equality checking, and then those are your logic operands. We will see them later, doing an and or, and then if you're doing any assignment, it comes afterwards, and then comment. Well, you can forget about this one. I will not touch in how to use comment in C for now, because it's really very rarely used right now. It's confusing and does not have much application. Right? We know the assignment operator. If I want to say x equal y plus d, then really well, the value that will come here. Some of the rules is that what if x and y and z have different types, right? How the assignment will deal with that. Oh, we are 8 minutes over the time. You guys are like very patient. Thank you so much. So let me see. Okay, so I will stop here. We can continue tomorrow. I will stay as usual for a few minutes to take questions. Okay. Yeah, I would make sure afterwards that I pay attention to time as well. Well, Arib, you had the full freedom to leave, right? So there is no mandatory attendance or report or anything. So it's in fact completely up to you. So and we have these recordings as well. So I would argue that, well, I know you were kidding, but I would assume, well, you are here with your full freedom choice, right? Okay, Caroline, there is a lab question, kind of a dumb question, but I don't like lab question one. Are we allowed to use if-else statements within the loops, or whether just limited for? Yes, if you need to, you can. Like basically the rules only that you have to stick to is what is stated in the question itself. The question never said you cannot use control statements as if. So feel free to use them if you need them. Right? Thanks, Sana. You too. Thanks everyone. Question from Sana: if we do 18 minus 4, would you still get 2e? Oh, negative. Well, this is what the bullet point was saying. This really application dependent on how the compiler toolchain is implementing the standard thing. So it's really left for the compiler. Sometimes you get 2, sometimes you get -2. It depends really on how would you assume. Well, basically the dilemma here is the sign associated to the result of the division or the remainder of the division, right? If you write it as, for example, if you do this, do you say I get -16 and then 2/4, or do you say I get 16 and -2/4? And as you can see, this is something really both are correct, right? So I guess you have to try it in your compiler and see which one it picks. Will an error be raised if we define an integer with a float? Well, what I was saying is that C has an automatic casting, right? As we will see later on, right? So we will discuss this example, Z-Wang, later on. Good. Okay, so thanks again, everyone, for staying after lecture time, and see you all tomorrow. Thank you. Bye-bye.